Baby, welcome to the party. Bitch, I'm a thot. Give me lit. Gun on my hip. One in the head. Send in the clip. Baby, don't trip.
Good evening, everyone. Kosi here. Good evening from my time and good morning or afternoon there. I do sincerely apologize for not being able to make it in person for the workshop. I was hindered by some unavoidable circumstances. But excitedly, I'm still here talking to you remotely on the topic building resilient Flutter applications, lessons for learning from platform engineering. This topic is going to be broken down into two sections. The first section is going to be introduction with subsections of my background, professional background, and experience I'll be sharing. An overview of what we mean by resilient Flutter applications. Then the next section, which will be a deep dive, designing Flutter applications for resilience. We're going to be talking about the importance of building resilient Flutter applications, principles we are taking from resilience or reliability engineering, and how we're going to be infusing them into the Flutter context. Once again, thank you for staying tuned, and I do sincerely apologize for not being there in person.
That you see I'm on, you wanna out me. What the fuck do these people know about me? Everybody on the block talk about me. Way back in the day you used to doubt me. Now that you see I'm on, you wanna out me. Got your boy feeling like I'm fat Gucci. Feds wanna do me, hoes wanna sue me. If you get some money, better bring it back to me. Everybody.
So let's take a quick view at my background and where this world of experience will be coming from. I'm currently a platform engineer at Okra. I'm a software engineer with over 6 years of experience in Java, Kotlin, Dart, Python, some JavaScript and TypeScript. I know, right? And of course, there are respective solutions for backend or mobile development, as the case may be. Before my current role, I had ventured into a few startups myself. Along the line, I was also working with a range of clients and employers from various sectors to provide innovative solutions which met their business objectives and expectations. Now, what does it mean for one to be a platform engineer at Okra? Now, Okra is one of the frontline companies leading the open finance revolution across Africa, and as such, we have a fleet of financial products and services which we offer as SDKs, libraries, APIs, etc. As a platform engineer at Okra, I specialize in designing and maintaining some of these packages, ensuring that they are scalable, resilient, and reliable. Today, I'm excited to be sharing with you some insights on how to build resilient mobile applications with Flutter, drawing on my expertise in the field as a platform engineer and software engineer as a whole. Okay. Now that we've gotten that out of the way, what do we mean by resilient Flutter applications, or what do we mean by resilient mobile applications? Excuse me. Now, firstly, I'll start with basic explanation. In layman terms, when we say a person or an item is given the attributes resilient, when we say that something or a person is resilient, typically it's said that such a person or a thing can withstand pressure or stress or challenges while staying true to their nature. Bringing it closer to home context of software engineering, when a system is said to be resilient, then typically we are talking about the system's ability to withstand disruptions, failures, while still delivering its intended services. Sometimes these disruptions could come up within the system scope. We're talking about internal exceptions or errors or failures. Other times is dependencies, the services, third-party dependencies. It could be APIs or it could be external libraries or things of that nature. But then, generally speaking, in tech, when one is talking about resilience, scalability, 90% of the time, what comes to mind is DevOps, cloud-hosted services, cloud applications, web services. Mobile applications or things that have to do with Flutter come as an afterthought. Why are we now? So it begs to ask, why are we now talking about resilience? Why are we using these terminologies in the context of Flutter or mobile, or in the context of client applications in general? If that curiosity is in your mind, then you have to stay tuned. You had better stay tuned. I believe by now I must have prepped our minds well enough with some level of curiosity as why we actually need to build resilient Flutter applications. Quick story: if you've been in Nigeria for the past 3 to 4 months, there's a high possibility you've been embarrassed multiple times by one bank app or fintech app or the other. As software engineers, we obviously know that a great portion of that blame goes to the various cloud infrastructures or services that these mobile applications are using, no doubt. However, these applications or the people that build these applications themselves do complicate the situation most times because they barely equip this app with necessary tools or checks to handle incidences. I'm talking about poor client side error handling, poor client side conditioning, I mean client conditioning, and sometimes in the heat of these frustrations, because I've been embarrassed myself multiple times, I do wonder if these apps are actually being monitored, because you experience an issue over and over again, you report, and the issue or whatever bug it is persists over a long period of time. So it's either these applications aren't being monitored or there's no little or no insights being generated from the logs of this whatever these apps are generating, or maybe it's plain nonchalant. Another indication that these apps aren't properly equipped for resilience is the fact that you'd contact a customer success or support agent via social media, most times social media, and they will ask you to please check your network connection. I mean, if my network connection is strong enough to facilitate a chat over social media, which should expectedly require more bandwidth with a social media application, then why is there a bank app or a fintech app is looking for some NASA type of connection? Well, however, the story gives you it's something I believe all of us can relate to as Nigerians. So it gives you a little background as to why we're talking about this, and then to give us some literature on the benefits or reasons why we need to equip our Flutter applications for resilience. I'll just read out a few things I've written down. Number one is something everybody knows is a no-brainer for better user experience. The entire goal of everybody's solution on the internet is for better user experience. And then that leads to obviously if your app has better user experience, then you have better app retention because users would come back to your app more or stay there more since their expectations are being managed and there are little to no issues that throw them off. Fraud and risk mitigation. Well, if your app is not properly equipped to handle some exceptions, some of these issues could expose some loopholes in your app. This will most likely happen if you there was no proper integration test done right before release, and it can expose some loopholes which could be exploited, and it can harm businesses a lot. It aids for faster debugging and issue resolution. There's a difference between when a developer has his app on his emulator or on his phone and you're debugging every issue that comes, you see it and you observe the stack trace and you fix it. Now you have your solution in the hands of thousands of people and the exceptions happening here and there. If you're not properly equipped, if you didn't prepare for this, it's going to take way longer time for you to fix issues for everyone. And the experience of every user is as good as the experience of 1,000 users because the ripple effect is always magnanimous. So this is another very huge advantage and reason as to why we should take this seriously. The last example or reason is an OS friendly mobile application. I know that almost every year or every 6 months or 9 months, we have all the OEM companies, Samsung, iPhone, etc., release top gear mobile devices, tablets are very powerful. However, they are also very pricey and the adoption rate is not as much as we expect. A lot of people are still using iPhone 7, iPhone 8, you know, a lot of people are still using, Techno and other lower grade Samsungs. So now if a resilient app will by, causal effects also be an app that is backwards compatible. Not because the latest iPhone we have latest iPhone is this and latest Samsung is that. You now say that everybody that is not using you now build your app that it can only run normally in these high grade and powerful devices. That's gonna make you drop a lot of users and a lot of your numbers basically drop. So and the another goal of businesses is to widen their target audience within their niche as much as possible. So this should be a concern. Now we're going to be looking into the principles of designing resilient systems, and most importantly the applications to Flutter development. So we're not going to be discussing everything as a whole. We're just going to cherry pick those that pertain directly to us as Flutter developers. And just three of them I've picked out from the many. So monitoring and alerting, scalability, and fault tolerance. Now a brief disclaimer before we go into this. Before we do, I want to say a few things that we Flutter developers should adhere to, resilient design aside. I would like to call out developers, including myself, sometimes reading documentation of any service, library, SDK, or plugin. We most times skip it and just pick what is important to us. Especially in Flutter, it's important because as Flutter developers, we are building for at least two broad but similar and mostly different ecosystems. I'm talking about Android and iOS. I know there's web, there's desktop. And so when I'm talking about reading documentations, I don't mean scanning through and grabbing what you need. I mean, every proper documentation has their caveats, fail points, exception handling, and important notes for the platforms they support, most times Android and iOS, and their use cases, talking about their SDK level or iOS version coverage, alongside misbehaviors that they've observed. So it's important to read the documentation properly and know these things so you plan adequately for them and how to handle them. Secondly, most Flutter devs, especially those who came into Flutter development from the JS stack, without any prior Android or iOS background, most times they lack a basic understanding of the working principles of the Android or iOS operating system. I know that whenever you write your Flutter code, they work, but technically, when we talk about an app really working, we mean when it's been battle tested in production. So it's your responsibility as a Flutter dev to make it a point of duty to keep in touch with what's going on in both any ecosystem you want to target with Flutter. Flutter isn't a programming language, it's a cross platform development framework built with the Dart programming language, DART. Now, it's your responsibility as well, like what I've expressed previously. It's still a valid responsibility of yours to read and study the Dart programming language and understand how it works. As expected, you're supposed to keep in touch, be up to date with Flutter documentation, with Flutter notes, etc.
Ọlọ́ládé mi Àṣàkẹ́.
àwa dédé àwa lọmọ tó ń sọ tí ó ṣèké yé orímọládé gbé mi débẹ̀ jìgànjìgàn ẹsẹ̀ mi ò délẹ̀ àlàyé mi stop ṣe bẹ́ẹ̀ ó fẹ́ jẹ́ ń bí mo tún fẹ́ jẹ́ ń bẹ́ẹ̀ ó pọ̀sẹ̀ àgbáwo fẹnu fò fẹ́ sún sẹ́yìn àmọ́ra wa ṣe kẹ́ẹ̀. Abínibí yàtọ̀ sábílítì ẹ sọ fún wọn tó bá tẹ́rìsì wọ́n máa pa lórí ìtẹnukọ́ èmi promise àwọn tẹ fọ́ fún mi torí kò sẹ́lù mi mẹ́ni fẹ́ dàbí mi ẹ̀rí bí ẹ̀kọ́ lọ́rùn tóbi mo dàṣọ ẹbí for my country you can call me Mr. Money. 230 fẹ́lù bóyá ká tọ́nà ilẹ̀ tó ń bọ̀. 230 fẹ́lù bóyá ká tọ́nà ilẹ̀ tó ń bọ̀.
The subheading is still resilient design patterns as it pertains to Flutter application. I have many examples, but then we'll go straight to fault tolerance. Now, fault tolerance, we'll be talking about resilient design patterns. I'll be in software engineering as a discipline, but now I'll be relating it to Flutter. Number one under these design patterns are the retry pattern or retry mechanism. Simply put, is the mechanism of retrying an operation on the event of failure or when an expected result is not returned. In Flutter, this can be used in single type operations with the possibility of mostly known failures. What do I mean by that? Let's say you're sending a post request to an authorized or protected endpoint. You already know from documentation of these endpoints, so you know that the expected error codes, and most people will handle these error codes, let's say unauthorized, not found, by just throwing an error, showing this an error. A slightly intelligent way could be applying the retry pattern here. Say it's an unauthorized endpoint, and the API already has an endpoint for refreshing this token. You don't sign the user out based on the use case. If it returns the error code with 400 unauthorized, you call the endpoints, you queue in the endpoints for getting the refresh token. Once the refresh token returns a new access token, you retry the operation again, and this time maybe it goes through. So that's one smart way of using the retry mechanism. Other use cases is an issue of temporal network problem and their packet loss, internal errors of the target service. Maybe when you get an error which is outside the scope of the error codes, which you know that this endpoint is meant to return, you can decide to retry the operation again and see if it returns a success this time.
I go, I know. I can't do without their policy, I go. I must fall in with all my niggas above. If they wanna bounce, person, it cannot be mine. Man just baku, it be like them be right. I can't do without their policy, I go. I must fall in with all my niggas above. If they wanna bounce, person, it cannot be mine. Man just baku, it be like them be right. Quack them, I they feel like they can rise. Reload, do like they can rise. Do like they can rise. Give the one problem, do like they can rise. Anytime I come, I go push them to the cup. Smack them, push them to the cup. They be stunner. Now me be their father. Reload tell me say na native be the matter. I leave Abuja come and cry, left my mother. To Addis Ababa, them go erect no placard. Bastard, now me dog in pillar. Now me Robbie Millers, I'm Kuronzi Piller. Now why are they pump us? I go do more than intended. I go shoot up on their playpens. I can't do without their policy, I go. I must fall in with all my niggas above.
If you've just listened to this discussion on retry mechanism or retry pattern and you're really thinking recursive functions, yeah, you're not far away from the truth. But there are, whether you're writing a recursive function to handle it, there are key conditions and factors that must be put in place. First of all, you have to have something called a backdrop. A backdrop is if while you're retrying this, duration of wait. How long do I wait before retrying? So you don't overload the server and you don't exhaust resources on the client side. And then at what point do I terminate? You can't keep retrying forever. So how long do I retry? If I retry the first time, the backdrop increases by 1 second, second time 5 seconds. At the third trial, you terminate. It's these conditions will vary. The numbers or details will vary based on your use case. But then it's important that you have these conditions in place. Else, it's not a retry mechanism. You're just recursively calling a function.
Happy on the asset social, man. Loyalty over royalty, y'all niggas know the vibes.
Fuck your kill this beat.
Whooped it, bitch, I'm outside of some movie. Blue cheese, I swear I'm addicted to blue cheese. I gotta stick to this paper like blue sleep. Bitch, I'm by my chicken like it's a 2-piece. You can have your bitch back, she a groupie. She just swallow all my kids in a 2-seat. Swagged out.
Another pattern is the fallback pattern or fallback mechanism. You could use this interchangeably. This is basically just like it says fallback. It's basically having plan Bs. We also refer to such implementations as redundancy. A good example is caching data, which seldomly changes, but is always in high demand by the user. I'll give 2 examples here. Number one is, let's say, Google Map navigation implementation on your app, where the user is always searching for a particular route or applying that route. You cache the most requested geo points or routes and other relevant geo data. Now, on the event of network failure or the network is slow, and we are always trying to manage user expectations and maintain stellar user experience. You plot the requested route using the cached geodata that you've cached before. However, this time you manage the user's expectation because the network is poor. You let them know the age of such data. Okay, this was cached 2 days ago, 1 hour ago, and then you also inform them that some features which are heavily dependent on the internet would not work. Things like traffic monitoring in real time, or real time navigation, because network is bad. And you also should use the network status until it's restored. Now, how would this work in production? Remember, the condition for caching in fallback mechanism is data that seldomly changes but highly sought. So this Flutter this Google Map implementation meets that criteria because routes don't change all of a sudden. You can't apply this route today and it's no longer there tomorrow. But map implementations on mobile applications are always highly sought. So it meets that criteria. Another example is users profile screen or users bio details on any screen. They do change, But people don't wake up and change their names, their phone numbers. Yeah, you can change their DP, but not all the time. Other details don't also change drastically. So it's reasonable to cache them and show the cache data on the event of network failure, or latency, or attenuation. But then, like I said, as a matter of responsibility and managing user expectations, you show them timestamp and the age of the data, and alert them that of the network status, showing them that network is down.
Sadlandosa, Gizon Indosa. 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 Sadlandosa, Gizon.
Next on the list is the timeout mechanism. And timeout mechanism is when an operation or process is being made to terminate after a stipulated amount of time without response. This can be used when handling time-sensitive operations like OTP validation, in cases where you need to conserve the resources allocated to the app by the host operating system. It also applies to apps that are designed to protect the remote server from long pending requests, which is most likely the case all the time. One has to be careful using timeouts though, because I'll give an example. If you use a timeout for an operation that is a sequence or has a process chain, it can lead to very horrible experiences. Imagine you as a user, you're placing an order, and then the user's network is not so good. So getting a feedback from the server is taking longer than usual. And then you trigger the timeout mechanism because time has taken so long. But the order has already been processed on the cloud and the user's account has been charged. So you're showing the user that this request timed out, but he has gotten debited and money has left his wallet. Now, on the client side, user has no proof that money has left his wallet because there's no other receipt or other ID or anything like that. It's just that his money has been debited, but money is gone. Of course, there's going to be a manual dispute resolution process like our banks have, but the psychological impact that it will leave with the user is terrible. And most times, it's going to affect retention because if there's a better alternative, the user will jump ship most of the time. This is why the timeout mechanism most times uses or goes hand in hand with the fallback mechanism. Because a proper implementation of the timeout mechanism always comes along with a fallback rollback operation. What do I mean? If you time out an operation, you fall back to the rollback operation most times to clean up. If you're using Windows, maybe a download fails or a Windows update or restore point fails, you see it rolls back its operation to ensure that everything that are left halfly done don't affect your system. So in this example we gave recently, if the endpoints were to be called with something I will call a rollback ID, which on event of timeouts, you fall back to a rollback operation which will hit a specific high availability endpoint with the rollback ID. And then, as the case may be, the server will now use the rollback ID, look for the operation, and maybe refund the user or now email since the operation failed but it completed on the cloud, but the user couldn't get, it didn't fail, the user couldn't get a response, but it completed on the cloud. Use the rollback ID, the server can now say, let me email the receipt of this order to the user. So the user can now follow up from there. Or if he stopped halfway but debit has been done, you refund the user and clean up every other mess. That would be a solid implementation of timeout mechanism with fallback mechanism. Thank you.
A storm is brewing in Metropolis. For years, Metro Boomin has protected the city from the unrelenting threat of evil. But the light of the Boominati headquarters, once a beacon of hope, has gone dark. In Metro's absence, villains rise from the shadows. Metropolis is on the brink of chaos. A powder keg, ready to ignite.
It's a play, not written very well, but it's a play anyway. Someone's a hero.
Walk a nigga
Someone's a
down,
villain.
walk a nigga down. Walk a nigga down, walk a nigga down, walk a nigga down.
May the hero in you prevail.
Come on.
And may you strike fear into the heart of any villain who dares to cross you.
Come on.
But you know what they say. If young Metro don't trust you, motherfucker, you better run.
Drinking dope, turn me to a superhero, yeah, yeah. Hit that pill, turn me to a superhero, yeah. Room my 90s, turn me to a superhero, yeah, yeah. If young Metro don't trust you, I'm on that dope again, I'm on that flow again, switch up the flow again, yeah, yeah. Fly in the parachute, gripping that pole again, I'm on that all again, yeah, yeah. Candy in the cup, gotta get paid. King in the streets, young nigga made. Spraying on the crowd, take it to the grave. Ain't having problems, I'm sipping the bar. Step on the swag when I step on the bra.
Top night feeling, time you be a hero, but live long enough to see yourself become a villain.